This, incredibly, is the 10th episode of this 454 engine rebuild. Everything has been torn down, cleaned up, and the important parts have been gathered, so it's finally time to put the engine back together. Most of the parts are coming from an engine rebuild kit made by Engine Tech. This has new crank and rod bearings, piston rings, and most of the gaskets and seals we'll need. And even though we cleaned a lot of the old ones, we still needed more bolts. So I ordered, well, a bunch, and it was not the last order that this project needed. We also have a handful of parts like a new timing set, oil pump, and cam and lifters. And with all of that on hand, let's unwrap the engine block and get to work. The first thing we'll be doing is installing a set of new core plugs. And to do that, we'll rotate the engine so the ports for the first ones we'll be working with are facing down. But why? Well, I probably should have done this before washing the block, but we need to clean up the edges of the holes for the core plugs before installing the new ones. And I figured that in order to keep as many of those abrasive particles as possible out of the engine, if we just face the ports down, hopefully the particles will just fall back out. There wasn't much rust or scale buildup on these at all, so some red Scotch-Brite should clean them up just fine. After that scuffing, we'll make sure to thoroughly clean them. And with that done, we can flip the engine onto its side where we can more comfortably install new plugs. Because I decided to use some sealer on the plugs, we want these ports free of oil, and some acetone on a shop towel will do that just fine. We'll be installing a set of brass core plugs because I greatly prefer them to their steel counterparts. I really don't think sealer on these is necessary, but I figured it was kind of a might as well situation. We'll be applying just a little bit of regular old RTV to the plugs, and we'll set the first one in place. To punch them into the block, we'll just be using a socket, this one happens to be 1 1/8", and an extension to hammer them in. The plugs need to go in straight, with the outer edge even and level all the way around. We'll set the depth of the plug to be even with the lower edge of the bevel in the engine block. And once it's fully installed, we'll carefully clean up any excess RTV on the outside of the block, mostly because it'll make the paint adhere to everything better later. We can double check that the depth is correct by peeking through the coolant port on the deck surface, and luckily that installed plug looks perfect. So we'll keep moving on along, and the second plug on the driver's side will get installed in the same way. And after that comes the third. Those three are looking perfect. We'll use more acetone to wipe down the outer edges one more time in an effort to remove any remaining RTV. Then, while we're here, we'll take care of a few threaded plugs on the same side of the engine block. The core plug set also included these new threaded plugs, which is what we'll be applying thread sealer to and installing. This first one will seal off the oil gallery all the way at the front of the block. We'll be tightening these NPT plugs by feel and kind of trying to align them in an aesthetically pleasing way. Once that's nice and tight, we'll wipe off the excess thread sealer and move to the next one. This plug seals off the water jacket and doubles as a coolant drain for the block. With that installed, next is this threaded port right above the mounting pad for the oil filter. And that about covers the driver's side of the block. We'll rotate it once more and move to the rear. First, we need to install and tighten down plugs into the 3 ports above the cam tunnel. 2 of these feed the lifters and 1 feeds the cam bearings. We'll be able to see this better with the front plugs, but when installing plugs like these, you need to make sure that they won't tighten down too far and block any important ports. In this case, none of them are interfering with anything, so we're free to get them nice and snug. And once those are in place, we'll also cap off the 2 ports at the lower driver's side. In order to get the socket onto this lower plug, we need to loosen and swing out of the way one of the arms on the engine stand. Generally speaking, 3 out of 4 is still plenty to hold up an engine, but make sure the others are very tight and be careful if you have to do something like this. In our case, it didn't present any problems and gave the clearance that was needed to install that plug. And with that in place, we'll reinstall the arm for the engine stand, and there's just one more threaded port towards the rear of the block, this upper one which typically feeds an oil pressure sender or switch. We'll be using this port with a mechanical gauge during testing, so we won't be installing any sealer and we'll just install a temporary plug. With that, there's just one more plug to install at the rear of the engine block, and that's the large steel one that blocks off the camshaft tunnel. Because of the block's positioning on the engine stand and my lazy unwillingness to remove it from the stand, installing this one will be a bit awkward. We'll protect the plug with a large flat steel washer and use a large punch to hammer it in. By continually moving our point of impact, we'll make sure the plug gets pushed in straight. This Gen 5 block has a little shoulder right behind the cam bearing, which is not something seen on earlier models. Because of that, I'm honestly not sure if it's possible to install this plug too far on this particular engine, and the factory installed plug was at least pushed in 1/8 of an inch past the bevel, but to stay on the safe side, it would probably be for the best to push the plug just as far in as you have to get it fully seated. I decided to install the plug similarly to the factory one, and once that looks about right, we'll flip the engine over once again and work on the core plugs on the passenger side. We'll face the 3 large ports down, just like on the other side, to clean them up. They'll get the same red Scotch-Brite treatment, and then, when the engine is flipped upwards, an acetone wash. Then we'll give the first plug a light coating of RTV and knock it into place. Then the second, and the third. And with those looking just right, we have one threaded plug on this side into a coolant passage. And with that tidied up, this side is done, so we'll flip the engine back upright and move to the front. Just like we did at the rear of the engine, the 3 ports around the cam tunnel at the front will need plugs. This was talked about when taking the engine apart, so I won't belabor the point, but the plugs we'll be installing are solid ones. The plugs that came in this engine are drilled down the center to help prevent noisy valve train startups by evacuating air. They also provide additional lubrication for the timing chain. I ended up going with regular old solid plugs because that's what the new kit came with, and I may have lost the old ones, but let's not dwell on that. Older engines didn't have drilled plugs, and it doesn't seem like something I need to be too concerned about, so we're just gonna stick with the solid ones. At the front here, we'll also take a better look than we could at the rear at the cam bearing oil passage. Here you can see how the port for that front cam bearing is in the threaded section of this gallery. This is why you need to be careful which depth the plugs are installed to. The best way to check for this is to measure the depth of that port, the thickness of the plug, and then measure the plug's depth once installed. In this case, that oiling port was about 1/2 inch from the front of the block. After calculating for the plug thickness at the base of the hex, that first installed plug is blocking threads all the way down to 0.52 inches. And once the other 2 are installed, they check out about the same. That depth means that the plug is up against the port but shouldn't be blocking it. And with those sorted out, we can move to a few plugs in the intake valley. This trio of 1/8 inch NPT plugs seals passages that had to be drilled down to those center cam bearings to feed them. So we'll make sure to get each of the 3 tightened down with care, and we'll flip the block totally over to work on the base of it. First, we'll thread plugs into these 2 ports, which would normally be used for an external oil cooler. We won't be running one of those, so we'll just block them off. And there's a little side note about that only occurred to me after putting the engine together, so it's something we'll have to take care of in the future. Back in the engine block disassembly video, we showed that there were 2 oil pressure relief valves built into the filter mounting pad. The valve offset from the center will keep oil flowing in the case of a clogged oil filter, and this valve in the center is the oil cooler bypass. Since we just plugged the ports for the oil cooler, that means all of the oil flowing through the engine will be going through this valve. And it's not necessarily the biggest problem, but it's not doing us any favors, and it's an additional element of complexity in the system. Before starting the engine, we will circle back to remove that valve, but for now we'll just continue with chronological engine assembly, and the next thing we'll do is install the oil filter adapter. This engine came with an offset adapter to help oil filter clearance around some components that we won't have to worry about. So instead we'll be using this standard style of oil filter adapter that just allows a filter to be screwed straight onto the block. It's probably unnecessary, but we'll put some thread sealer on that and use a hex socket on the inner diameter to tighten it into the block. I wasn't able to find a torque spec for this, so we'll just get it tight. That covers all of the plugs and that adapter, and we're finally ready to move to some of the bigger parts. Before we get any farther, we'll use some more acetone to thoroughly clean all of the cylinder walls. This always manages to get even more out of cylinders that were already looking pretty good. We'll run a shop towel around each cylinder until it comes out clean. Obviously, we don't want any grit in there for when the pistons go in, but before we get to that, we're going to be doing some measuring, so we want the cylinders as clean as can be. To help keep this data organized, I made these printouts specifically for this engine with data separated into a few different tables. To help us fill those out, I bought this tool, a dial bore gauge. We'll be able to use this to get some accurate dimensional data about the cylinder walls. Normally this is something you would do before you're actually assembling the engine, but in this case, I wasn't really gonna do anything about this data unless it was way bad. This is more something I wanted as a curiosity to see exactly how bad the cylinder walls ended up after all of that honing. To take a reading with that dial bore gauge, we first need to set it up using a micrometer. This one is lightly clamped in a vise and locked at the measurement of 4.250 inches, which should be the starting point for the inner diameter of the cylinders. We'll zero out the gauge to the micrometer, which means its 0 represents 4.250 inches. With it set up, we can carefully insert the gauge into a cylinder and take an accurate reading of its diameter at one location. Here we're measuring towards the top of cylinder number 1. By rocking the gauge back and forth, we'll look for the lowest reading, which represents the actual diameter at that point. That measurement in the direction of piston travel came out to 4.254 inches. And if we measure perpendicular to that, where there's usually a little bit less wear, we come out with 4.252 inches. Then we'll once again measure in line with the piston travel, but this time towards the bottom of the cylinder. Typically, this wears less than the top of the cylinder and came out to 4.252 inches. Perpendicular to that, it measured at 4.251 inches. That covers one cylinder, but of course there are a few more. We'll measure each and every cylinder in that engine block the same way we just showed measuring cylinder number 1. The numbers turned out pretty much as expected, and we'll go over those in just a minute. But what are they actually telling us about this engine? Well, there's one more thing I want to do before we talk about that, and that's measuring the pistons themselves. Let's go ahead and unpack those and lay them all out on the table. We'll take the piston from cylinder number 1 and use that same micrometer to measure the skirt diameter. Typically, the widest part of the piston is the base of the skirt, and we see that here with it measuring 4.248 inches. In fact, we measured all of the pistons and they all came out to that same number. So now that we have that in addition to the cylinder measurements, let's look at the numbers for a second. There are a couple of critical values here, and the first one is just the plain diameter of the cylinder. And surprise, surprise, every one of our diameter measurements is outside of the range of the factory specification. But the more important real-world number is the piston to bore clearance. And if we look at the difference between the piston diameter and the largest measured diameter for each cylinder, we come out with 0.006 of an inch for most cylinders and 9 for number 7. Again, all of those are outside of our specs, but the 6s are pretty close. That 9, though, is actually abysmal. Another critical measurement is the amount of bore out of round. That's what that perpendicular measuring of the cylinder was telling us, and it comes out to 0.002 of an inch. That value is the upper listed limit for out of round, but our measurement is within that spec. The last big one that we'll talk about here is bore taper. That's the difference between the measurements at the top of the cylinder and the bottom. Cylinder to cylinder, the calculated taper varies from 1 to 4 thousandths. Only 2 of them failed to surpass the factory specified limit of just 1 thousandth. And once again, cylinder number 7 is just embarrassing me. That's causing a lot of movement of the piston rings and is likely to wear things out pretty quickly. But at this point, in the name of budget and experimentation, we're already pretty committed to doing some questionable things with this engine build, so we're gonna keep moving forward. Though unfortunately, that means a bit more measuring before we get back to assembly. Next, we'll be checking out the main journal diameters of the crankshaft. The listed range for journal diameters is 2.7482 to 2.7489, so all of these should be right inside of that range. There was also no out of round that I was able to measure on any of the journals. So what about the rod journals? We measured each and every one of those at more than one position and they all came out to 2.199 inches. The listed range is 2.1990 inches to 2.1996 inches, so as closely as I can measure, they are all right in that range. They also show no signs of being out of round. As it turns out, the crankshaft is just about the most perfect part of this entire engine. Which is great and all, but none of that's very helpful if the actual bearing clearances aren't any good. So we'll step back from the numbers for a minute and get back to the engine block. With it flipped upside down, we'll take brake clean to each of the main bearing saddles and the main cap mating surfaces. We want all of these surfaces dry and very clean. It's also time to unwrap all of the main bearing caps that we cleaned, and crack open the pack of new main bearings. These are standard size bearings, just like the ones that came off of the engine, and they should be a perfect fit. Just like we did for the engine block side, we'll use brake clean on each of the main caps to remove any oily residue. The only thing left on these is that thin coating of WD-40 we left on them, which is very easy to remove. We'll also use brake clean and shop towels on both surfaces of the new bearings. It's sometimes surprising how much will come off of the surface of those clean looking parts. And once there's no more residue coming off of each one, we'll start putting the bearings in the main caps. The large bearing with the thrust surfaces goes on the rear cap, and for each of the others, all we have to do is line up the tang on the bearing with the slot cut into the cap. Each bearing should press down into the cap by hand and should be a nice snug fit. And once all 5 of those are in, we'll do the same thing on the engine block. That wide bearing presses in at the rear of the block, and each of the others slots in, once again making sure the tang is where it needs to be. Of course, it's also important that the oiling holes in the bearings line up with the ports in the block, and luckily they all do. Once those are in place, we'll go grab the crankshaft and very carefully lower it into the block. We won't be putting any oil on anything just yet because we're going to take a measurement. We'll be checking bearing clearances with Plasti-Gauge, these little wax strips that we'll place on each of the main journals. And once all 5 of those are in place, we'll start dropping on the main caps. First up is the rear cap. We'll be using this mallet to help persuade the caps into fully seating. We'll get the 4 smaller caps into place, making sure they are installed in the correct order, and then give each one a few taps until it is fully seated up against the block. And once all of those are in place, it's time to dig out the main cap bolts. Once we have those ready, we'll apply oil to the threads of each bolt as we drop it into place. Of course, the shorter bolts go on the outside ends of the caps, and the longer bolts go towards the center. Once all of the bolts are in place, we'll go back through and put a drop of oil underneath the head of every single one. This, and the oil on the clean threads, ensures a consistent and repeatable amount of torque when tightening, which is the next step. First, we'll go through and snug down all of the bolts, just looking to get them threaded in. Some spots, like this cap on the end, might need a little bit of persuasion to get the bolts perfectly lined up. And with all of those snug, I am lucky enough to have the opportunity to go through and start torquing the caps down. First, we'll do a pass on each and every one of the bolts at 30 foot-pounds. We'll follow a standard 4-bolt main torquing sequence, which involves starting at the center 2 long bolts and working out in a spiral. Then, once we get all the way through, we'll tighten the 2 center short bolts and work our way outwards in a spiral once again. And once all of the bolts are at 30 foot-pounds, we'll go over them again and do 70. And hooray, we get to do it again, this time at 102 foot-pounds. I am very glad to have this relatively long-handled torque wrench for this. Once we're finally done with that pattern, we can stand back and admire our work. For about 10 seconds, because now we have to go through and take all of those bolts back out. We'll follow a standard detorquing sequence, which is the reverse of the sequence we just followed to tighten them down. Then all the bolts can come out, and we'll use 2 of the long ones to very carefully rock loose each of the main bearing caps. I emphasize carefully because we don't want to squish or move the wax strips in any way that might distort them. And we definitely don't want the crankshaft to turn during this process. Once again, that rear cap really didn't want to go anywhere, and it took some hits from the mallet to remove it. It seemed like everything came off cleanly enough that we were able to get good information from the plasti gauge. All of the wax strips are still there, squished against each of the journals, and pretty uniform in size. The rear one still has half of it stuck to the bearing cap, probably because it was so hard to dislodge it. We'll measure the width of the wax streak left on each of the crankshaft journals. The first 4 come out to 0.002 inches, and the 5th journal comes out to 0.003 inches. Specs for main bearing oil clearances for the first 4 are between 1 and 3 thousandths. That 5th wider bearing usually has a bit more clearance, and the spec is 1 to 4 thousandths. So as close as we can measure, all of these clearances look absolutely perfect. Which means it's time to install the crankshaft for real. We'll go ahead and wipe the plasti gauge off of the journals, although it's not strictly necessary, and lift the crankshaft straight up and out of the block. We're taking that back out so that we can coat the bearings in assembly lube. This stuff is extremely tacky and will stay where you put it, even as we rotate the crankshaft during reassembly. We'll make sure each of the bearings and the thrust bearing surface are thoroughly coated. And we'll do the same for the other halves of the bearings that are installed in the main caps. Then, for hopefully the last time, we can drop the crankshaft back into the block. And just like before, we'll slot in the first 4 main caps. Before we put on the rear cap though, there are 2 things we're going to take care of. The first is this little O-ring that sits underneath the cap on the block side. I believe this is only a Gen 5 and 6 thing, but it helps seal the unfiltered oil going through that main cap. And with that in place, we're also going to install the rear main seal. Doing it before the main cap is in place is probably a little controversial, but I figured it would be easier this way. We'll slip the oiled seal over the rear of the crankshaft, and then we can drop on the main cap. We'll seat it with the mallet just like before, this time also making sure that the seal isn't pinched in the process, and proceed to seat the rest of the caps. The torque procedure will be exactly the same as last time, so we'll speed through it. The oiled bolts are placed in the caps. All of them get snugged down, and the crank gets pushed forward and back to set the thrust bearing, and we'll torque them all to 30 foot-pounds, then 70 foot-pounds, and finally 102 foot-pounds. And with that last relieving click, the crankshaft is fully installed. Of course, before we go any farther, we need to make sure it turns easily. The only felt resistance to turning seems to be from the thick assembly lube, so I think we're in good shape. And with that, while it may be a little anticlimactic, we will be ending the episode here. This time around, we covered a lot of the detail work and measuring, and by the end of the next episode, we should have a complete long block. Oh shit. There you go. Very important.